personally obsessed with disasters and things going wrong in a very big way. And I thought it will just be interesting and somewhat comforting for people in the room to see how things go really wrong. So, you know, maybe you have a bad day, maybe you lost 7 minutes of data for a client. He was very upset, you were very worried you may lose your job. At least you didn't blow up an entire city, you didn't kill 300 school children. Things are relatively okay and under control. Our mistakes are typically manageable, I think with the exception of Eric over there, who in a bad day is capable of causing a slightly bigger, he's working at CERN, and I think he's capable of causing slightly bigger disasters than the rest of us. And I also believe that from disasters, we can learn lessons. And again, I'm not talking about IT disasters, but after years of reading up disaster stories, just as a personal hobby, I noticed that while disasters are usually very different, they are in general also very much the same. The same causes keep repeating over and over again. It's always this person who didn't have the right training. It's always two people who didn't talk to each other. It's always procedures were always not followed. There are very few things that lead to very major disasters. And hopefully, if we're more aware of the things that we do that are very likely to cause a disaster down the road, even if it's not a major disaster, even if nobody will get killed as a result, it's good to know what things could avoid, and you can kind of say, oh, we're doing that. And I know that this kind of thing leads to a major disaster 3 months down the road, so let's not do that. And you can tell your manager, look, we're doing this exact kind of thing that we're doing in Chernobyl. And that's a pretty convincing argument. We don't really want to cause a major disaster. Let's stop this trend when it's still small. And as a disaster expert, I'm also aware of different models of how disasters happen. And there is a bunch of them. And one of the most popular ones, the old school model is the root cause model. It says that every disaster has a single root cause, and we have to talk to people, we have to do postmortems, we have to keep on shifting blame a lot. In the end, we will find the root cause, we will fix whatever caused this disaster, and after we go through it enough times, there will never ever be any disaster in our system again. And that's a very optimistic model. How many of you have been in a postmortem where people were looking for the root cause? Yes, almost the entire room. It's a very popular model. How many of you, when you found the root cause, you fixed it and you felt very confident that this type of disaster will really never happen again? Oh, wow, that's even worse than I thought. It means that there's no managers in the room, right? But yes, in general, we don't really believe that. We find something, we call it the root cause, and we kind of know it's not really their root cause. The disasters are more complex, which is why people now use the Swiss cheese model. It basically says that any complex system has many layers in it, and you need a lot of things to go wrong because you have the R sites and you have all kinds of checklists and safety measures, and you need a lot of stuff to go wrong at the same time. You need the new engineer in the system, and a disk just failing, and he couldn't get his manager on the phone, and the network to the DR site was just having issues, and the second DR site was just getting upgraded. You need a bunch of stuff to really cause a disaster. One root cause doesn't really do the trick, so you cannot really point, oh, it's the new engineer, because the new engineer would have been fine if we didn't have the disk failure, the network failure, and the upgrade. So that's the Swiss cheese model, and it's usually correct, except when it isn't. Some disasters, and I will talk about them in a minute, really have a pretty simple cause. You can point at two ship captains and say they were drunk and the ships ran into each other. And it's not always that complex. And also, sometimes you have a root cause, but because people are so anxious to find more and more causes to kind of shift the blame around, it looks like a Swiss cheese model from the outside because everyone is finding so many causes that you say, oh, there are so many reasons for the disaster to happen, while there was one root cause and a lot of inventions and noise around that. So that's something that also happens. And without further ado, let's talk about disasters. So 1986 happened to be a particularly bad year. I mean, every given year has disasters. 1986, I think, had more interesting and media disasters than usual. Oh, it looks even better on a large screen than I imagined. I like it so much. Okay, do you want to do disaster bingo? Like people will point to things and recognize which disasters I'm going to talk about? Come on, some of them are so easily recognizable. Okay, we have the Challenger in the lower right corner. Yes, we have Chernobyl on the center up. And then on the left, upper left side, it's the K219. It's a less known one. It's a nuclear submarine that sank near the US coast. It happened to be a Russian nuclear submarine that sank near US coast. The chemical plant up there is Bhopal. That was not actually 1986. It was 1989, but it's still a good lesson. The trains are the biggest train incident in the history of the Soviet Union. And that was one of the disasters that has such a simple root cause that it's ridiculous. It's a very short story, but I had to include that because it's a huge disaster that was it's rare that disasters are so clearly defined. The Challenger, of course, is a very famous story because a very famous guy wrote a very lengthy document about the investigation. Richard Feynman was part of the group investigating the causes for the Challenger, and he wrote very clearly about what caused the issues. And then there are two ships that sank for different reasons. And again, same year, 1986, both are Soviet ships. And those are also pretty good stories. So I collected some of my favorite disaster stories, all happen to happen in the same year. And it's only by mistake that almost all of them happen to be in the Soviet Union. Completely random, absolutely nothing to do with the place where some of my managers came from or anything like that at all. So Chernobyl is actually one of the more fascinating disasters that happened because it was a very long, very complex chain of events. And that's also the longest story. So if you get bored in the middle, you can start tweeting. Everything that comes after that will be kind of easier to follow. And I have to admit, I simplified chain of events in disasters a lot. But the geek in me doesn't let me oversimplify because I keep thinking, no, without this tiny detail, nobody will really understand the story. So I hope I got it correct. Let's try and see. So the actual reason for the disaster started long before anything happened. The new reactor for the Chernobyl nuclear site, nuclear power plant, was added in 1984, which was 2 years before the disaster. And it was actually missing an important safety feature. So nuclear reactors generate a lot of heat, and they kind of need cooling water to rotate around them in order to disperse the heat. And in order to do that, you need a power source. So normal operation, you have a power plant, you're okay, you have a power source. But when you need to do some kind of maintenance or you have an issue, you may have some kind of a power problem, but you still need the liquid to keep on flowing. So they had diesel engines as a backup. And those diesel engines could do their job, it was tested, but they had 2-minute ramp up. And they needed some way to cover the 2 minutes between the points where the turbines for the water pumps stopped working until the diesels came online. And they saw that residual heat in the system could actually be used to continue. So they can kind of keep on going just using residual energy in the system. And of course, they have a nice theory. Now they have to test it. They tested it once, it failed. Tested it again half a year later, it still failed. And basically, by 1986, the power plant was running for 2 years without a safety system. And everyone was understandably concerned. So for the day that the disaster happened, the test was planned. And you can understand that no one was willing to skip the test or delay it for any reason. The test had to happen. There was a lot of pressure around that. And because of the pressure, a lot of safety procedures were not really followed and a lot of just, not even safety procedures, just processes. People skipped the process. They didn't get the right approvals. The engineer of the plant one of the head designers of the plant wasn't notified because they decided to kind of skip some notifications. So it was already kind of a shaky start. But on the day of the test, they started gradual, part of the test was shutting down the reactor, and they started shutting it down at 1 a.m. with the idea that the team arriving in the morning will carry out the test after power was supposed to be at a very narrow band around 700 megahertz. That was the idea. Unfortunately, at the time where the test was supposed to start, another power plant supplying the same region had issues. The director called the director of the Chernobyl plant, asked, can you please continue supplying the usual amount of output for a few more hours until we fix our problem, otherwise there will not be enough power in the region. Fair enough, the test was delayed, and the time when the issue in the other power plant was fixed and the test could continue was at 11 p.m. That means that the day shift that knew about the test and knew how to perform all the tests and were supposed to do the test were no longer in the plant for several hours at this point. The test could not be delayed, of course, because very important test, everyone was looking at it. So they had to run the test with people that were never trained, were never briefed, they were basically following a list with instructions. They never did any of these activities. Whoops. Okay, they start following the procedures. Part of the procedure was to, again, reduce the power output to a certain degree. But actually, because of various mistakes that were made, it dropped slightly below what it was supposed to go. So it was 500 megahertz instead of 700. And because of some kind of, it's called reactor poisoning, a lot of xenon that accumulates in the core, it continued dropping further, resulting before the test in a near shutdown. Of course, this is not supposed to happen, so they started attempting to restore power. How do we do it? We start taking out control rods. And because we started taking out control rods, the power went up a bit, but there was still some of the xenon in the core. They took it a bit more. They got to a point where almost all the rods were out. It was producing power, but much less than it was supposed to. It was around 300 megahertz. What they didn't know is that the computer was controlling some of the rods to stabilize the power output. But everything looked okay, but it was really unstable. Temperatures were fluctuating, and so on. At some point, a lot of alerts started going on about the temperature fluctuation. And they basically decided to start a test when the core was already in a very unstable state. And that's just the beginning. That's just when they said, okay, let's start testing. Even though we don't have the power output we need, even though alarms are going off, even though we are kind of suspect but don't really know how stable the core is. And at that point, they shut down the turbines, they started diesel engines, and expect power to carry things over. As a result of shutting down the turbines and starting the diesel engines, water stopped flowing. That was the entire point of the test. And if everything was normal, it would have been just another failed test. But because the plant was already unstable and the water was very close to their boiling point already, less water means they had to absorb more heat. Temperature of the water started rising. It became steam, meaning it absorbed less and less energy, meaning the temperature of the plant went up, meaning more steam. This naturally leads to an explosion. At this point, just a second. Okay, before I'm mixing things, before the first explosion even, things were behaving strangely. They had power output going out of control. Nobody knows why, but emergency shutdown of the reactor was started. It could have been decision of the automated computer system. Maybe a person panicked. Maybe someone thought it was part of the test. We have no idea why, but emergency shutdown started. And when emergency shutdown starts, it means that all the control rods that until now were outside in an attempt to generate a lot of power output were slammed inside as fast as possible. A nice feature of the reactor meant that as the rods go in, they push water out. Of course, we already didn't have enough water. Temperatures were going up. We just pushed the remaining water out before the roads went in. Whoosh, an explosion. That was the first explosion. The explosion caused the control rods to break, shift, some fuel cells moved and shift. So there were a lot of control rods that were still outside and couldn't be inserted. At that point, power started rising really sharply, more steam buildup. The control panel got to its limits and could no longer show any accurate reading. And because the control panel at this point stopped operating, nobody has any good idea of what happened next. Everything I tell from now on, pure speculation based on computer models. A lot of that is completely non-reproducible. But what we think happened is that the second explosion, caused by steam buildup, managed to blow apart the entire reactor casing. So large blocks of cement flying all over the place. The hood of the reactor, which weighs 2,000 tons, flew up. It must have been a sight to see, absolutely. And that caused just no water left because everything is breaking apart. Of course, power keeps climbing. There was another explosion. Nobody knows exactly what caused the third explosion, but we suspect, but don't know that that was actual nuclear reaction. And that explosion actually dispersed all the nuclear material, and at this point, there was no longer a danger of another nuclear explosion, and no danger of continuing chain reaction. But now you have bits of radioactive material dispersed all over the place, and a lot of steam and smoke and fires with those radioactive material going out of the plant into the entire area. And at this point, which was very late at the game, remember, cement and nuclear material and everything is flying all over the place. The shift lead, who was responsible for the operation of this reactor, looked at his Geiger counter, or dosimeter, which only went from 0 to 3, which is still a very safe reading. So it was kind of a narrow band and very accurate reading, but it didn't really go into dangerous levels. And said, oh, I see it at the maximum, but that's still okay. Ignoring the fact that he has burning debris all over the place, because the monitor has to be correct. At some point later, they bought a new monitor with a larger band of reading, and the reading was so far off the scale that everyone thought the new monitor is broken, because we can't possibly be seeing the amounts of radiation we actually are seeing. Of course, the new monitor was correct, but the human ability to ignore evidence all around you because the monitor has to be right is amazing, and it's not limited to Soviet nuclear power plant operators. So, and that's just, and I'm on my third slide, and it's still just the beginning, because now they have to clean up the plant. And they have workers coming in, not knowing that they're exposed to extremely high level of radiation, and they just, go in and start spraying water and clean this mess up. It was pretty amazing, the level of human negligence that went on there, but I'm not getting into that. So obviously, there has to be a lot of committees to find out what happened, some of them secret, some of them more public. And of course, we point to all the usual factors. Procedures were bypassed, operators made many mistakes, operators had no clue what they were doing, and then we have the human error factor, and then there is also the engineering factor. The idea is that the hotter the plant gets, the less effective the cooling system becomes, because it relies on water for cooling and water evaporates under heat, is a feature in the power plant that is almost built for disaster. I think most power plants these days are not built that way. And the idea is that if you insert the control rods fast enough, water will get out, and for some few seconds, you will not have cooling at all. Another dangerous design point. The plant was not compliant with all standards. Of course, people believed the monitors when they had absolutely no reason to believe them. And because of the test, half the safety systems in the plant were disabled. So tons of causes for disaster. That's definitely a Swiss cheese model. I mean, you just have to fix those wait for the day shift, just stop the test, just call someone who knows what he's doing, something. So that's one of those. Oh, dude, yeah, it did take all my time. I may not be able to cover all the disasters. The Challenger, I think it's more well known, at least here in the States. Not in Russia? You didn't hear about the Challenger in Russia? No, actually, actually, in the beginning, I only collected Russian incidents, and then someone told me that it will look like the only way to avoid disaster is not be in Russia, and that's not entirely accurate. So just for those who didn't reiterate it through their grade school over and over again, basically the Challenger was a space shuttle that went on multiple missions. On the 10th mission, NASA made the decision to have a school teacher on the shuttle, so there was a lot of media attention, and I think I heard statistics that 85% of the US households at the time were watching the Challenger launch, which is, I think NASA couldn't hope for worse publicity ever. And I think that's part of the reason the incident was so well researched, is that everyone had eyes on it. And that's, of course, another IT lesson. There are some incidents that will get way more attention than anything else. So what the sequence of events was that they have a solid fuel tank, and it was just next to an external fuel tank with, I think it was hydrogen. A flame from the solid fuel tank somehow found its way into the external tank. What I'm saying is not 100% accurate. I'm missing a lot of details on purpose. So this is only one slide. I didn't go into 3 different slides. But this flame caused the tank to release some hydrogen, and the tank kind of moved out of its way, slamming straight into the tank holding oxygen, liquid oxygen. This collision resulted in naturally massive explosion. And the question was, how did the flame get from the solid fuel tank to the external tank? That caused by a failure of a single O-ring. And the reason the O-ring failed was that it was not designed to operate under the temperatures that the shuttle was scheduled to lift off. And that's it. That's one of those incidents that are maybe very complex, but have a pretty specific root cause. The O-ring was at fault. Of course, now we want the root cause. It's not enough just to have a root cause. Why did a bunch of very smart people use a faulty O-ring? Did they know there was any issue? What happened? So, of course, there was a very famous committee researching the causes. And they found out that NASA had an organizational decision-making culture that didn't really allow anyone to dissent from party line. So if an engineer saw that the O-ring is supposed to fail at temperatures that happen to be those during lunch day, he couldn't really say that to his managers and get listened to. And that's a very common cause of incidents. Someone knew exactly what is going to happen, warned everyone he could, or in some cases he just warned his direct manager. He didn't really make so much noise about it. Engineers have this tendency to not always make a lot of noise about things they know will go wrong. So they say, I told my managers that, yes, this is not going to work. Okay, and what happened? Nothing, they ignored me. Okay, what did you do next? Nothing, but it's not going to work. It's pretty common. We do that a lot. And it's kind of, I think we lack imagination in manipulating our organization. We don't always have ideas of how to make our voice heard. And I think that's, sometimes lives depend on it. Yes, management, the problem with the O-ring was well known. Management disregarded warning from engineers because they didn't want to hear. The launch was public and important and looked really bad to delay it. Of course, not as bad as having it blow up, but it was very easy to imagine that things are safer and we are going to be lucky and it's just a tiny O-ring. The O-ring was not certified for those temperatures, and there were other issues with the same ring. And the most important, there was no really test data. The reason it was not certified, nobody tested it in these conditions. And it's pretty common that we do things and don't really test. And what I'm doing valid? Did everyone did it ever? Did I ever did it? Is it going to, do I know for a fact it's going to work? And yes, customer intimidation is what I hinted at. Something was so visible, we couldn't possibly delay it, so we have to take the risk of it blowing up. It's pretty common. And then there was a kind of controversial cause. Edward Taft, which is a very, very famous visualization expert, made a point that the engineers did not present the data correctly to management, and therefore management did not know how to make the right conclusions, because the chart didn't show clearly what the engineers knew. And that's a good point in terms that, yes, you have to show data to managers in a way they can understand. You cannot just throw formulas in them and expect that they will figure things out. On the other hand, the engineers at NASA, who are not exactly stupid people, say that Taft really didn't understand their data. His chart, where he attempted to correct it, is all wrong and uses the wrong axis and wrong scale and mixes air temperature with the O-ring temperature, which are not the same thing. And if you go to very smart people at NASA or engineers in your organization and tell them, look, you're doing your job all wrong and this is why your shuttle crashed, they may take offense. Okay, the K-209, that's the Soviet submarine that crashed near US shores. It's one of those stories where the root cause is very clear and the chain of events is just horrific. Things going from a little bit bad to horrible to totally wrong. So the K-209 was a nuclear submarine and rumored to be carrying very, very secret Russian weapons, and it was patrolling near Bermuda, which is dangerously close to the US, which is why big part of the reason things went so wrong. The existence of the submarine had to be hidden, not to mention what was on it. And it was very important, basically, that it was a higher priority that the Americans will never, ever be able to look at the submarines than anything else. So the disaster started when a seal in a missile hatch, something went broken. Of course, it's a submarine, it's underwater. If something breaks in the hatch, water flows in. It interacted with the fuels that was somehow there, and that started by causing a lot of poison gas to disperse. Then there was a fire, then there was a big explosion. Obviously, the natural root cause question is what caused the missile hatch to break. The Soviets say that there was an American submarine that ran into it. The Americans say, we don't know what you're talking about, there were no submarines in that area ever. In those conditions, it's very difficult to find the exact root cause. It may have been an American submarine, and it may have been something else. We have no idea. Okay, they already had one disabled missile hatch. They felt unsafe. One of the things about nuclear submarines is I find it the scariest thing in the world. I mean, nuclear reactors are scary. And if it's a nuclear submarine, then it's a nuclear reactor in a very tightly closed and very small metal container with about 50 to 200 people underwater, a lot underwater. So pretty much if you're on a nuclear submarine and something goes wrong, you know your chances to survive are near zero. And of course you have management who prefers to sink the ship and kill you than ever having anyone else look at it. So let's say I would never take this job. Statistically, being on a Soviet nuclear submarine is significantly more dangerous than being on any other type of nuclear submarine. So you need to take that into account when choosing your future career. So they actually did a sensible thing. They said, okay, we're sitting on an atomic bomb underwater, and things are going wrong, let's take it up, shut down the reactors, and get things under control. Very sensible approach. Went up, tried to shut down the reactors, and apparently the method for shutting down the reactors, and I never found out if it was the official method and that was the method they ended up using, involved someone going into the reactor, pressing a few buttons, and going out in time before he dies from radiation poisoning. The door on the way out did not work in one of the two reactors, and already at this point a guy died, horrible death, while his friends watched him from outside. That's just for a beginning. At that point, okay, they even have one reactor that is in unclear state, Obviously, everyone just wants to get out of there. They called home and said, we need to get towed out of here. No problem. There was actually a ship around capable of towing them out. Towing attempts were unsuccessful as well. Things didn't connect as expected. They didn't manage to make the equipment work as they intended. While all that was happening, more and more poison gas from the reaction of water and fuel kept dispersing through the ship. Yes, obviously, people wanted to get out of there as fast as possible. So against instructions and against orders, the captain decided to evacuate everyone to the towing ship. I think it was quite sensible. Soviet command disagreed with me, and they demoted him and promoted his second in command. The second in command did continue doing exactly the same thing, evacuate everything to the towed ship, because that was the only sensible thing to do. And at this point, the captain refused to leave the ship, the demoted captain. I think he could have had good reasons. I'm not sure I would want to go back into Russia after I disobeyed direct orders in 1986. He decided to stay in the ship. The ship sank a few minutes later. There's pretty good evidence, but nothing conclusive, that he sank the ship on purpose. Either it was his idea to sacrifice himself to prevent the Americans from getting the secrets. Maybe he was ordered and it was a secret order. Maybe he just went mad. Nobody knows what exactly happened, but everyone was moved to the tow ship, and the captain stayed behind and sank himself. And the ship in him sank, maybe on purpose. Not a lot of IT lessons here, really. But it's still a good story, right? What? Take the database. No. Oh, don't be on a nuclear submarine. Okay. The Admiral Nakhimov was a Soviet Navy ship that was converted to a passenger ship at some point in the 80s. And it just took passengers from one location to another. Very unexciting. Most of passenger ships don't have any issues. Big disasters like the Titanic are pretty rare. In this case, the chain of events is pretty clear and pretty horrible. A few minutes after the voyage started, the captain noticed that he is on a collision course with a large carrier freight ship. And he radioed the other ship and said, look, we're on a collision course, what do we do? The captain of the other ship said, oh, no problem, you don't have to do anything, I'm taking care of it, don't worry, relax. The captain did something unbelievable and actually relaxed. He put the second in command in charge and went off to sleep. The problem was that no one did anything. So the second in command was under the impression the other ship is handling it, so he kept going. The other ship didn't do a thing at all. So as they were getting closer, and we're talking now about 10 minutes before crash, he started radioing the other ship frantically and saying, we are going to collide, we are going to collide, what are you doing, we are going to collide. And the other ship didn't answer at all. Eventually, both ships ran into each other. At the last minute, both captains tried to do last-minute maneuvering. So one of them broke shoreside, the other of them tried to brake and go back, reverse engines. They did all kinds of maneuvering, way too late. So the freight was okay, it just ran into passenger ship. Passenger ship, yes, it got a large hole in the side and eventually sank. It sank really fast because it was a very large hole. I think within 7 minutes, there was no ship left above water at all. Rescue crews arrived 10 minutes later, and some people were rescued, not that many of them. The unofficial root cause is that both captains were drunk at the time of the incident. And that's a very important lesson. Don't ever have a drunk captain. The official explanation is that both captains were negligent, they didn't obey safety procedures, etc. So don't be drunk and do obey safety procedures. Okay, another ship that dramatically sank. I think only one person died in this incident, but it looks amazing, right? That's the Mikhail Lermontov. It's a Soviet passenger ship that was cruising with a kind of elderly passengers on a cruise next to Australia. and they were sightseeing and stopping at ports, and all was really nice. And they left a place called Picton. Any Australians who actually know where Picton is? I couldn't find it on the map. So, yeah, so the ship, somewhere in Australia, the ship had an experienced, even though it's a Soviet ship, it got an experienced Australian captain. And everyone was very relieved to have a very experienced Australian captain who knew the waters really well. And he also believed that the cape they were supposed to going next to, it had a kind of a passage, and he believed the passage was twice as wide as it actually was, and that it didn't have any dangerous rocks in it. He was so sure about those facts that he didn't really read a chart or anything, and he wasn't really supposed to go through the passage. He just thought that it was be nice sightseeing and the passengers will enjoy that. So he made last-minute decision to go through a path that was actually half as wide and way more dangerous than he would have known if he bothered to look at the charts. His officers told him, look, we didn't plan this, we don't really know about this place, do you really think we should do it? And he was like, yeah, okay, I've done it a million times before, it will be great, don't worry. That's famous last words ever. And obviously heat rocks, which actually were there, and water started pouring in, pressure increased, fell over to the side. He managed to beach it on time because, again, the passage was pretty narrow, so everyone was evacuated out. One of the crew members died during the evacuation attempt, and that was it. Not a lot happened, but I think it's so classic engineering mistake. I mean, this is, in my experience, the times that I make huge, horrible mistakes that look a bit like that, is that when I'm so confident that I know what I'm doing, I don't need to look at the documentations. I don't need to check what server I'm on. I don't need to call the customer and say, are we really supposed to? We did it thousands of times already. Nothing can ever go wrong. That's exactly where things go wrong the most. Okay. Let's see. Last incident. Ufa is a town nobody ever heard of in Siberia. And you seriously? Wow, okay, I'm gonna shut up about that. And it was also a site of one of the easiest to explain train incidents ever. So the engineers there was a gas pipe going very close to train lines. And it's usually done that way because it's very easy while you're laying down train lines to also train down gas pipe. It's very easy to do maintenance when you have a train getting all along the gas pipe. Engineers at the service station noticed that in the monitors that pressure is dropping in the pipe. Of course, that means, of course, not enough gas is being serviced. They increased the pressure. Pressure decreased again. They increased it again. Decreased again. They still increased it again. At some point, at the point of a leak, not far from the famous town of Ufa, there was a very large cloud of easily ignited gas leaked from the pipe. At that point, 2 trains carrying school children from vacation, just to make it extra fun, pretty full, going in 2 different directions, past each other. And of course, it's trains. There's a lot of things going on. A spark happened because, you know, lots of metals close to each other, and this ignited the entire thing. Whole thing just blew up in very impressive flames. That's one of the incidents that I say are so impressive, and they have such a simple root cause. I mean, the pressure drop, you increase the pressure. The pressure drops, you increase the pressure, and not one time anyone goes and say, why does this happen actually? I already increased it 3 times in a row. Maybe there is a leak somewhere. So as a result of this incident, the Soviets actually added, they call it a pig robot, which is the best name ever. And it kind of goes along the track and detects leaks. So you actually have double monitoring. You don't just have to rely on the pressure. But I think that if you get the same alert over and over and you keep fixing it and it keeps going wrong, maybe an extra check would be in place. I think I'm going to, okay, actually we have 20 minutes? No, we actually have 10 minutes left. Okay, let's do this one fast because it's a good one. Bhopal is a site of massive poison chemical leaks from a pesticide plant. The plant was eventually owned by Dow, who are the people paying for the damage many years later. But at that time, it was owned by some kind of United Chemical company. And the plant had a history of leaks going back 7 years before the actual incident. And actually, the year of the incident, there were a lot of leaks. It happened every 2 months, something else happened. The engineers knew that there were a lot of issues. Things were not being maintained. There was not enough money. Half the systems were disabled. There was warning, warning, warning. And all the warnings were, of course, ignored. Ignoring regulations as well, one of the tanks contained way more of a specific chemicals than what was supposed to be there. For some reason, nobody knows why, but two terrorist groups took responsibility for the incident. Water entered one of the tanks, and there was an exothermic reaction. Exothermic means things are getting hotter. So the engineers in the plant wanted to relieve pressure on this tank. They just opened a valve, allowing all the poison gas accumulated in the tank to escape out into the near town of Bhopal, where many people actually lived. Yes, the fact that nobody knows how water entered the tank, and this is what the management really focused on. We had sabotage, it shouldn't have happened. Well, yes, but you didn't have any safety systems either. So, and your engineer just released a bunch of poison gas into the near town. So, yes. I want to finish with tips on how to avoid disaster. Other than avoid being in Russia, which, as you saw, was a major cause for disasters. It's very dangerous. You did the right thing. So it's very important to communicate. If engineers warn you that there is a problem, you definitely have to pay attention. But even if someone calls you from the other room and says, look, we have a problem and you're not directly responsible, talk to him, find out what's wrong. Maybe it will have impact on you. You never know. Maybe he's running straight into you. Don't ignore issues. I think one of the major causes in all disasters is issues that are known issues. We know there is a problem, and we let it stay in the system and just kind of get used to it and ignore it. This is exactly the kind of thing that is going to bite you later on. And that's when you go and say to your manager, yes, that's what happened in Bhopal. Do you want to be responsible for 500 people dying? You don't ignore almost incidents. In almost every case, before the actual incident happens, there are a lot of things going wrong, enough to indicate that there's going to be a big issue later on, but nothing really major happens, so we ignore that. You want to investigate almost incidents like you would actual incidents. You never ever ignore monitors. And the number one cause of people ignoring monitors is that the monitors are too noisy. So you don't want monitors that goes off every night at the same hour and that's nothing and everyone gets used to it and everyone ignores it. You want every alert to be really important and everyone to pay attention, because in every single incident there was a monitor saying something is wrong that people were already too used to ignoring. You always troubleshoot issues. That's almost the same as fixing issues ASAP. But also, again, if you fix it, it goes back, it comes back. You fix it, it comes back. Go and find out what's really, really wrong. Don't just let it be in that strange state. Don't ignore processes and procedures. I'm a hacker. I love ignoring processes and procedures. After studying about enough disasters, I try to control myself. Yes, these procedures suck. I hate change management. I hate filling all those forms. I have to do it anyway because things go really wrong. Again, in Chernobyl, they didn't follow procedures. You don't want to cause that type of incident. And of course, if someone doesn't know what you're doing, you really should have a way to get someone who knows what he's doing on site ASAP. And remember the Swiss cheese theory. You want to be able to have a lot of many layers of protection, because every one of them can go wrong, and you have to have many in order to really stop disasters. That's it. Thank you very much for listening. I have tons of fun. Telling my favorite stories to a captive audience. My husband usually runs away midway, so I love it. Usually when I mention Russians for some reason. Yeah. Cool.